Okay.
תודה רבה.
Okay, so first thing, before we understand why objects are mutable and why primitive types are immutable, first of all, we have to understand how primitive types and objects are stored in memory, and then we will understand much better why they're mutable and immutable, okay? So the thing is, there's a golden rule. Primitive types are stored as values in memory, okay? And objects are stored, object types you could say, right? Object types are stored as references in memory, okay? What are primitive types? Primitive types are, as we know, there's a string, right? String, number, Boolean, undefined, okay, whatever, how I spell it, null, and symbol, right? Those are our primitive types. And objects, as we know, they are objects itself, right? We have objects, we have arrays, right? We have functions, and we have also sets and maps, our new data types, but we haven't gone over them yet, right? But they're also stored as references, okay? So what do you mean by primitive types are stored as values and objects are stored by references? This is the key words over here. Let's make an example. Let me make something called let first name, right, equals Chris. And then we have let second name equals first name, and let me just make that a capital, right? What's going to happen when I'm going to console log these guys? If I'm going to log first name and second name, what's going to happen?
Chris.
It's going to be Chris, right? Okay. Let's just do no demo, right? Demo. Cool. Yeah, it's going to be Chris. So what happens is in memory, what's going to happen is once I'm going to make a first name. So let's just pretend I'm in memory now, right? Of course, it's more complicated than this. I have first name, right, equals Chris. So I have a designated place in memory that first name has the value Chris. It's always going to be Chris, right? And now when I say second name equals first name, so then I have something called first name equals Chris, right, in my memory. And then I make a new memory with second name, right? A second name, and it's going to be Chris as well, right? It's separate places in memory. It's not referencing the value here. It's going to be two other places. So what happens now if I write first name, I'm going to change it to Max. What do you think is going to happen, guys? If I'm now going to console log
Max Chris.
underneath. Max Chris, yes. It's nothing surprising here, right? Because like I explained in memory, what's happening now is I'm going to change my first name to Max, right? And it's not going to change my second name, right? Because I already have this in a separate place in memory, right? It's very understandable how it works, right? There's nothing new over here. Also, you can even go further, right? If I'm going to console log first name.
מה קרה ליחידת מידע של קריס הראשון, של first name, הוא נמחק?
הוא נמחק, יפה. So there is garbage collectors in JavaScript that automatically collects garbage, like useless values that you do not use anymore, and they destroy them. Right?
כשאני שם משתנה אחר על יחידת מידע שהזנתי למערכת, זאת אומרת, second name מצביע פה על קריס, בזמן ש-first name זה קריס ו-second name זה קריס גם כן, למה הוא מייצר תא זיכרון חדש ולא רק מצביע לאותו מקום?
למה? Because, okay, I don't want to get into it, but this memory stack, there's this thing called memory stack. It's very fast. It goes straight to the value itself. Usually if you want to make more complicated data like objects, it's stored in a different memory. That's why it creates a new variable, a new reference in memory, because it's very fast and doesn't take a lot of memory to do, because it's just one string, right? String, booleans, undefined null symbol. They're just something very short and not complicated. That's why to be more efficient, it's not going to get a reference, because if you have a reference, which I'm going to tell you soon, objects, it takes more time to actually get the data. And this is super, super fast, right? And it's never complicated, strings, numbers, booleans. That's why they store in a different memory, just for performance issues, right? For performance. Okay, so now
it's the value that is stored as memory and not the type.
The value, yeah, the value. Yeah.
So this is why the object as a wrapping of types that contain values is just a reference.
Yeah, okay, we're gonna get there soon. Wait, let me just go to objects. Let's just talk about the primitive types. I'm gonna jump to objects and it'll be more understandable. But just understand, now this is in a separate place in memory. This is in a separate place in memory, right? I could even go further to understand under the hood if it is the same place in memory. If I do first name, you know what, let's just delete that. Not delete that, but let's just do it like that, right? If I do first name equals second name, what's going to happen? Am I gonna get true or false? Gonna get true. Actually, wait, this should not be first name equals second name.
It is true, yeah.
No, it is true. No, actually, wait.
They didn't. You got the max.
Oh yeah. Sorry. I didn't delete that. Yeah, sorry. It's false. Yeah, sorry about that. I changed it right here because these are in two places in memory, right? I have Max and Chris, so it's pointing to two different places in memory, right? When I do this equals sign, it's basically saying inside memory, are you in the same place, right? Are you the same value? It says, no, it's not. I am false, right? So we can go with numbers as well, like very quickly, just to show you, it's the same thing, right? If I have let A equals 1, right? And then I have let B equals A, right? And if I'm going to console log now A and B over here, right? I'm gonna get 1 and 1, right? The same thing, because I'm taking it inside. So inside my memory, I have like A is 1, right? And then I have B is 1, and now if I'm going to change A to 5, right? And if I'm going to log now A and B, right? I'm gonna get 5 and 1, because in memory, it's going to be A is now 5, right? And B hasn't changed, right? Because it's taking the whole value. It's not referencing the value in A, right? It's doing a whole different memory in different memory place, right? So that's also with primitive, with numbers, right? You could test it with booleans, undefined, null, and simple, right? But they're all the same. Set up? Understood? Yeah. This is not that complicated. I mean, this is how you think it should work, right? Which it does work, right? So it's not that complicated. But then when you're gonna go to objects, right? I'm not going to do it with object itself. You're going to learn it today, but it's exactly the same thing. So I'm going to play around with arrays. If I have const my array here, right? I have 1, 2, 3, 4 inside here, right? And here I have a const my array 2, right? And then I'm going to actually take my value that I have in my array, right? And if I'm going to now log my array and my array 2, right? What's going to happen? Actually, you know what? Let me just copy this. I'm just going to delete all my console logs here, so it'll just be that. What's going to happen? It's going to be not found. Oops. What's going to happen is, of course, as you can see, just like the variables, right? It's going to be 1, 2, 3, 4, and then also my array 2 is going to be 1, 2, 3, 4, right? It seems the same. It seems the same, but what happens now, guys, if I'm going to take my array, for example, right? And I'm going to change the position 0 here to something else, like hello, right? What's going to happen now in my console log, guys? What do you think? God, whoa, what is happening? Also my array and also my array 2, which I didn't even touch, right? But we saw over here, it's different, Nahon? It's totally different. But what happens actually in memory, guys, is this. Yeah. So what happens now, actually, what happens actually, guys, when I'm going to, let's say, create my array here, actually, objects are by reference. Objects do not directly get access to its values in memory, because now let's say we're in memory here. My first name gets direct access to the memory, right? they don't get direct access to memory. There is a pointer that points to the actual memory. So under the hood, right? If I have my memory over here, under the hood, my array, right, doesn't point straight to 1, 2, 3, 4, right? It doesn't point straight to it. Actually, in between there is a pointer. There is a pointer that directs to that specific value in memory, right? So if this happens like this, and now when I actually am going to create a new variable with reference to my array, it actually does not copy that value, it copies the pointer. So now in memory, for example, I have this one, right? And now when I created a new variable, I'm creating a new pointer to that memory because I'm only copying the pointer. So what happens now is in memory, if I'm going to change now hello, for example, here, right? I'm changing actually that value in memory, right? So that's why my array 2 will get that same value because it's just copying the pointer of it, right?
מה array עצמו, איפה נשמר? השם של
השם של my array? I'm not actually too sure. It's somewhere stored in memory, right? But
in the stack memory, כאילו זה נשמר בסטאק, בכתובת שנמצאת בטהב, כי מה שבתוך התוכן זה נשמר בהב, memory, ואז הכתובת של ההב נשמר בתוך הסטאק.
Okay, but let's not get too deep in it. I just want to give you a high overview. Of course, we could get much more deeper of how the heap and stack works and exactly where it is, okay? But I just want to give you just not to get too complicated. I'll read you articles about it. And if you really want to go inside the memory, how it exactly works, בשמחה, I'll give you some articles to read. But just a simple...
ב-JavaScript קוראים לזה reference ולא pointers, שלא
יתבלבלו. Yeah, sorry. So it is a reference, sorry. But yeah, it creates pointers, which are references, right? Sorry, it's not pointers, they're references, okay? I think of them as pointer references, right? But of course they are references. They're references to this exact value. Thank you for that. Okay, so as you can see, if I'm going to change anything, right, in my array or my array 2, it's going to change the value here. And then I have references to both variables to this value. That's why it changes, okay? That's why I could go even further, right? If I'm going to now console log my array, right, equals my array 2. What am I going to get, guys? I'm going to get true, right? Because they point to the exact place in memory. נכון? Awesome. This is freaking amazing.
שווה זה לא בדיוק בדיקה לרפרנס, בגלל שאם אתה תעשה 1 שווה 1, או כאילו קודם כששנים הרגילים, אז מה שזה בודק זה את הטייפ ואת הערך, ולא באמת את הכתובת.
Okay, that's true. Okay, but I could just kind of think of it like that, but okay, maybe you're right on that. Okay, but anyways, regardless of this, you guys understand this? Super important. And when you understand this, you understand why you need to make copies of your array, right? If we modify something in our array now, right? And if we have reference to it in a different variable, both variables change. And it has bugs in it, right? It makes code unpredictable. Because this is very simple, right? But if you have thousands of lines of code, right? And you have references everywhere, and all of a sudden you're going to change one of those reference values, and then all of your code is going to go to shit, if I could say a swear word, right? And so it's increased vulnerability to introduce bugs, right? Especially if multiple people are working on the same code, right? They don't know that this is a reference or something like that, right? Because this code I could get somewhere in line 3000, right? I didn't know this was actually a reference, נכון? It's harder to test, obviously. It's hard to debug. There's no support for time travel, right? So if, for example, I wanted to look at my array 2, it changed. There's no way that I could see what was the value beforehand, right? Why is this changed now all of a sudden? So you can't do time travel, right? So that's why in JavaScript, there is a lot of ways to create new arrays on the fly, right? Because JavaScript knows about how these objects are stored in memory, right? And they don't want you to have bugs, right? They like you, they're not against you, right? So they're giving you these methods to help you. So we have all of these ways for creating copies. So for example, to creating copies, we
הנה,
already
אפשר
know
לשאול
quite
על
a
זה
few.
משהו?
כן.
במה שהראית, נניח עכשיו אני שולח את זה לתוך פונקציה, אז אני לא צריך להחזיר את המערך ממנה והוא ישתנה לי גם נגיד אני שולח את הפונקציה לתוך מערך, זה גם רפרנס? אני משנה אותו ולא עושה ריטרן, אז זה גם משנה לי את הפונקציה, את המערך בפונקציה?
Yeah, I believe so. כן, why wouldn't it?
בלי להחזיר כאילו את המערך.
זה לא בגלל שזה פרמטר, מתייחס לזה בתור...
זה פרמטר,
כאילו זה גם רפרנס, מה שאני שולח ל...
I have to check that. I'm not too sure. I think so. That's a good question. Does anybody know the answer?
לגבי משהו קודם, אם יש לי מערך A 1, 2, 3 ומערך B 1, 2, 3 ואני עושה שווה שווה שווה, בדקתי, הוא אומר false, אפילו שהמערכים שווים.
Because it's in a different place in memory. It's a different place in memory.
אז זה כן בעצם בודק את הרפרנס. זה לא בודק את התוכן, זה בודק את הרפרנס.
זה בודק את הרפרנס? יפה. Okay. So that was true when I did console logging. So thanks for that. Okay, cool. So that's a good question about the functions. I really believe that actually it modifies it, but let me just double check on that. But besides that, guys, we have creating copies. We create a lot of methods in JavaScript. It creates copies of the array, right? We know slice, nachon? We already know that. We know the spread operator, right? That will create a copy. We also, guys, you haven't learned this yet, but there's also filter that also creates a new copy. We also have map that creates a new copy. And we also have reduce that creates a copy. This is just another method in an array that you could do some computation, right? And it creates a new copy right away, because usually with reduce and map and filter, you're trying to modify something of the array, right? And so it automatically creates a copy, so you won't get this balagan, right? Of these references. You're going to learn about filter, map, and reduce more next week, okay? But there is so many methods for that, right? So now, very important, guys, when you're creating copies of, let's say, an array or an object, it's only shallow copies, right? You guys touched about that yesterday with wet spots, but let me just reinforce it. What is shallow copying? So it copies, it's only shallow copying, okay? Very, very important. Let's make an example to understand what is shallow copying, okay? Let's say I have const an array 1, right? And then I have 1, 2, 3. Let me just actually delete all my console logs. 1, 2, 3, 4, right? And then I have a const R2, right? Sorry, R2. And then I'm going to make a copy of this, right? You can make it in all your different methods with slice, with spread operator, right? That we all know about. Concat as well. I forgot about that. Concat also creates a new array, right? But so for example, I'm just going to do it with R1.slice, right? So it's going to create a copy of it. Actually, you know what? Let me give you the different methods of how to do it, just to give you a reference over here, okay? This is a slice method, right? This is how you do it with slice. And then this is how you do it with the spread operator, right? If I have now, let's say, a const R3, right? I'm going to create a new array, right? And then what I'm going to do is I'm going to spread all of the elements inside R1 inside my new array over here. This is the fastest way, guys, to actually copy an array, a shallow copy. But this is the fastest way, so I recommend that you guys do this. Understand the spread operator, because we're going to use this a lot in React as well, okay?
What's the difference between using the 3 dots, the spread, and not using them? Because it does almost the same thing, right?
It does the same thing, but under the hood, they have a sophisticated algorithm that performs faster. I'm not sure exactly what it does under the hood, but understand that the spread operator, it does exactly the same thing, right? But the algorithm is more sophisticated, and it makes it more faster to copy an array, okay?
But I meant like putting the array 1 between brackets without the dots, right?
Yeah, so I could do this, right? But what's going to happen is, again, I'm going to have a reference to this, right?
No, is it? Yeah.
Wait, if I'm going to log this, I'm going to have an array of an array, actually. Sorry, no, I'm going to have an array of an array.
Exactly.
Yeah, and I don't want that, Nahon. I don't want an array.
It works the same way.
Yeah, it works the same way. Yeah, exactly. Sorry, it works the same way, right? But then spread is just spreading all of the values inside here to here, and it's not taking the array along the right. Yeah, good one. Cool. So, I mean, there's a slice and the spread operator, right? These are two things that you guys need to know actually to how to create an array, right? There's the concat as well. You can do that as well, but this is ES5. This is the old way of doing things, right? Yeah, don't need to have that. Cool. So now, before that, let's now do some shallow copying, right? This was all shallow copying, sorry, right? Because this is shallow because there's no embedded array or object inside there.
Can you speak about the spread operator?
So I'm going to say it again, guys, okay? I'm going to give you some articles as well to understand what a spread operator does. Basically, what it does, it's spread operator you can use if you can iterate over something, right? You have an object as well. You can also iterate over it, right? So you're going to learn today an array, you could iterate over it. Even a string, you could iterate over it. All the iterations, what you can do, you could use a spread operator. So what it's doing, you could think in simple terms, under the hood, it's doing a for loop. For loop, and it's taking each element, right? And it's iterating over it, and then it's placing it inside this array over here, in simple terms, yeah? Soon you're going to learn about objects today, and you're going to see the spread operator there as well. Array 2? Array 2?
ואיפה הוא לא עובד הספרד אופרייטור גם?
מה?
איפה הספרד אופרייטור לא עובד? במה אפשר להשתמש בו?
בספרד operator, if it's not iterable.
תן לי דוגמה למשהו שלא iterable?
Like a number? Like a number 5?
Okay.
Something like that, right? Oh, I got unexpected. I have this thingy. What's the, so it just creates the new array, 1, 2, 3, 4, right? Same thing.
לא, אבל שנייה אחת, אז זה מה ששמתי לב לזה. אם אתה עושה כאילו דרך סלייס, אז הוא עושה לך קובי לארי. אבל אם אתה משתמש בכאילו ספריד אופרטור, כאילו מכניס ארי בתוך ארי.
No. But if I do a spread operator, if I console
הוא מכניס ארי בתוך ארי. מכניס ארי בתוך ארי.
It's going to be just, it's taking all of the elements inside over here, it's just taking it like that and then spreading it inside here. That's what it's doing. It's not taking the array itself. It's spreading all the elements inside there. If I did just like this without the spread operator, it's just going to copy everything and also the array as well.
Even if what you have inside is not 1, 2, 3, but different arrays or objects.
Oh, we're getting there. So this is shallow copying. That's all. Only when it's shallow, only if there's nothing embedded here. So what is a deep copying? What is a deep array? Let's make an example of that. So I have something called...
Can I have a question before we go to the deep array? The shallow copying does not mean that it's a copy that affects one another, that they have the same pointer, because from what במהלך השיחה שלנו, אני בדקתי קצת, זה מה שראיתי בגוגל. המשמעות של shallow copy זה מבחינת המבנה של הארי, או מבחינת הזיכרון שלו ואיפה שהוא מאוחסן?
Okay, let me do the deep array, and then I'm going to change the two different things and you'll understand it more. Let's just do the deep array first for a second, okay? And then I'm going to get back to the shallow copy because it's okay? So now let's just say I have a deep array, right? Something kind of deep. What is it? What is a deep array anyways? If I have, if I have 1, 2, 3, 4, like we had over there, but then I have another element over here, which is another array, right? And I just say hello, or something like hi, right? What is this? So I have the shallow array here, and all of a sudden I have a deep array over here, right? I have an array inside an array, right? So when I'm going to copy it, I'm also definitely going to copy the hello and hi, but when I'm going to try to modify it, things are going to get funky. So if now, for example, I'm going to, let's just do const R4, right, is deep R slice, right? I'm just going to copy it. Now, if I'm going to log R4 and deep R, right? Let me just let me just take that and let me just delete all the other console logs, right? if I'm going to have that, as you can see, guys, I have an array over here, and I also have an embedded array inside my array, right? With hello and hi. So how can I access this embedded array? So what I can do is I'm just going to console log, for example, just a deep R, right? Where is it? It's in 0, 1, 2, 3, 0, 1, 2, 3, 4. It's in the index of 4, right? So if I console log 4 now, I'm going to get my embedded array here, right? Because now I'm accessing this entity, which is an array. So if I could nestle deeply inside it, I could go now inside my array, right? Now I have an array here, which is 0 and 1. So if I want to access the value of hello, right, I'm just going to go inside here and I'm going to write 0. So now I'm going to access the value hello, right? This is how you access like deeply nested arrays. Cool. Okay, so now when I understand this, now actually I want to change it. I want to change this value, right? This value to something like bazaar, something like that, right? Now I'm changing this to here, right? But what happened here in my R4, I created a copy of it, I created a copy of it. It should be a brand new array, right? It shouldn't affect R4, but now when I'm going to console log R4, right? Inside here, what's going to happen? Waza and waza, it actually infects it. So when you copy an array, it only copies the shallow part, right? So the reference inside the deep array, you don't actually have it. So that's why it changes together, okay? That's
if you add more elements into the array, like a 5 or something, it won't affect the R4, right?
No, let's see. Now I have a 5, and I'm gonna say something like a 5 or something like that. Oh, sorry. I'm gonna just put something like 100. No, it didn't affect it.
It's only
for deep elements. Yeah, that's a good one. Yeah, so it doesn't affect the shallow, doesn't affect, right? But the deep does.
אז אם רוצים להעתיק בעצם מערך שיש לו deep array, אז בעצם פותחים מערך באורך של המערך הקודם ומעתיקים רק את ה-deep array?
There's ways to do it with the for loop. You can do it with a for loop, right? You can do it actually with the JSON object. It's a bit complicated that you convert this to a JSON and then you make a copy. But there's also things like Lodash, I think Wespa showed, right? The Lodash, if you want to make deep cloning of an object, right? You could use Lodash for it. You could see in Google, right? I never done this myself. Never needed to use it, right? But if you do, you could just try Lodash, right? Or you could just Google, there's like a JSON way to do it as well. But it's, anyways, by a native JavaScript, right? Simply, you cannot do it, okay? Only shallow copying, so be aware of that, all right? אוקיי, כן.
אתה יכול לרדת לדוגמה האחרונה שלך. אז בעצם בדוגמה האחרונה, 1, 2, 3 ו-4, יש להם מקום חדש בזיכרון, ב-deep R, ב-R4, סליחה. ורק hello ו-hi הם קלון, הם מצביעים על אותו מקום שמצביע deep R. זאת אומרת, אין להם מקום משלהם, יש להם פוינטר משותף עם R. זה מה שאתה אמרת עכשיו.
Exactly, there is a pointer for them.
because if I... לו לבנות את הדאטה בתוך הזיכרון, זאת אומרת, כי יש פה ערבוביה מטורפת.
It is, but the heap is a very complicated memory place. The thing is, also, yeah, the heap is a very complicated memory place. It's like dynamic, and it's more... I'm not sure how it works, to be honest, but I have to read more about the heap, right? But you could get into it too if you want to. But that's how it works basically. In our end, to understand it, right? This is enough to understand how it works, okay? To get into the detail, I have to read more about it as well. But
אז איך מומלץ באמת להעתיק שיהיה...
If it's a shallow, cool. You could just use slice, right? And use...
לא, אבל אם צריך דיפ.
Lodash. There is a library called Lodash. First of all, I don't recommend you guys use this at the moment, right? Because Lodash gives you like how you call it, methods that you don't need to do yourself. And so kind of like a library. It's really interesting to actually read the documentation here and see how they do the different methods, because they make it so efficiently, every single thing, even looping an array or doing some very, very normal stuff, filtering over something, right, that we could do in native vanilla JavaScript. But the way they do it, they really do it in performance ways, right? So Lodash is a good thing, but to be honest, I never used Lodash before. I didn't need to use it. I like to do it natively, everything, because I want to learn as well. I want to do it natively to understand how it works, right? But then when you're going to have some more complicated things, right, you could use Lodash, but I don't recommend in this course, do not touch Lodash at all. No, 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 right? We want to learn how to do it by ourselves, okay? And after that, when you're in a company, right, a lot of people use Lodash, right, just to make it more faster and to make it more efficient. Your algorithms, okay? But at the moment we're learning, right? So we don't want to touch this. I haven't touched this myself, right? But Lodash is one, right? And also you could just Google deep cloning algorithms, right? And then it'll give you some sophisticated code to do this. But to be honest, I never did deep cloning before, only shallow copying. But for example, in Redux, in React, right? It uses it under the hood. When you're going to create a state, a copy of the state, it also copies the deep cloning as well. So you don't even have to touch it. You have libraries and frameworks that do it for you, right? From React and from Redux, right? That you don't even have to do deep cloning. But if you do vanilla JavaScript, right? Yeah, definitely do with Lodash deep cloning. Cool.
תסביר את הדוגמה האחרונה שוב, כאילו עשית shallow copy ואז מה, כאילו פשוט ניגשת לזיכרון ושמת...
shallow copying? No.
אני שמתי לכם דוגמה דומה בסלאק.
Okay, תסתכלו בסלאק חבר'ה. I want to get to the next nose. Yeah, this is important. But hopefully you do understand it, that it just makes a shallow copy of it, right? And this is actually a reference. It points to this R1 and deep one points to the same hello and hi in memory, okay? And then when I'm going to change the deep R, right? It's the same thing over here, that it's pointing to the same place in memory. So if my deep R here changes to hello, for example, right? And then it changes to both of them, because it's nested deeply. It's only a shallow copy. The nested array is actually pointing to the same reference, okay? Cool. So now we understand this, right? Let's just do a little sikum. What's going on here? So primitive types are stored as values in memory, right? So if I have a string, number, Boolean, and if I create a copy of, for example, first name, right, for a string, it's actually going to designate it in a different spot in memory. That's why when I change the first name to Max, right, it won't change the second name, because second name is isolated in memory, not even connecting to the first name, right? It's creating a new place in memory. That's why when I change Max, right, it doesn't change Chris, right? Also with numbers, the same thing. We have an array. An array actually doesn't, when you say console log my array, right, it doesn't right away access, it doesn't go to the memory directly. We have a reference pointer that points, that references to that specific memory, right? When I do console log, it doesn't right away go to the memory. It's actually getting that reference, right? You can even say reference is like an ID1, for example, or something like that, right? And here's an ID1, so it knows exactly where to go, right? You could think of it like this. That's why when I'm going to change, I'm going to make a copy of my array to my array2. I'm not copying the value of my array, I'm copying the reference, right? That's why when I'm going to change my array to hello, for example, my array2 will change because I'm getting the copy of the reference, right? That's why it changes, okay? That's why you should always create copies, because of this mistake over here that you could get a lot of bugs on it, right? And it's only to do with shallow copying, because if you have an embedded object inside an object, right, it will get a reference to it, exactly the same as here below, right? Above, sorry. Cool? All right, now I want to talk about mutable and immutable in JavaScript. So JavaScript objects are mutable, right? What does mutable mean? That is, you can change them. Cool. And we know what objects are, right? They're exactly the same thing as this one, right? So I'm just going to copy this over here. Let's put it here, right? Okay, and then we have JavaScript primitive types. JavaScript primitive types are immutable, right? So it means you cannot change them, right? Cool. And then let's just get a reference over here. What are actually primitive types? But we already know that, right? Cool. So let's do this before. How will this work? This is okay. So let's have let my string here, right? I have a string called hello, right? And so now in memory, right, I have something called hello. So in my memory, I have something called my string, right? And it points to hello, like this, right? And now what I'm going to try to do, I'm going to try to change the string to something else. I'm trying to mutate this string, right? So now I'm going to do, for example, my string, right? In the bimkom efes, so I'm going to change the H. I want to change it to a T, for example, right? What's going to happen to if I'm going to log, actually, you know what, let me just.
You will change the H to T, right?
All right, let's see. I don't know, man. Maybe I'll error. Okay, let's see.
Hello.
It doesn't give you an error. It gives you is you cannot change it. Yeah, maybe if it's not, it should give you an error technically, right? If you have good linting, probably there is a setup that you could do with linting that will give you an error, right? But it doesn't change it. You cannot change a string. You cannot change a primitive type. It's not allowed. So if I wanted to change this, right, I had to make a new string, right? That's not in that memory. So if I have const new string, right, I can take my string and, for example, I could slice it, right? I could slice it. So that means I'm going to take the ELLO here, right? And then I could just make, for example, a T here and make a plus sign, right? That will now change it to tello, because here I'm just creating a copy of that string, right? If I have a new string over here, it should show me tello, right? So that's a way to modify or to mutate.
Vinny, you can do replace also.
You can do replace. You can do so many different ways to do it, right?
You can also write my string equals T plus the slice you did.
You could do that too. Yeah, you could do many ways. I'm just showing you there's thousands of ways you could do that, right? But you have to create a new string, right? You can't modify the hello here. So now what happens now is, so I have a hello. So what I'm trying to do here, Nahon, in memory, just to give you a reference, right? I'm trying to say hello, right? Which you cannot do. You can't modify this one, right? And change the string. It's immutable. You cannot change it. But then I have a question for you guys. Okay, it's immutable. Cool. I understand this. But what happens to a number, for example? If I do now, for example, let my number, right, is 1, for example, and then I change my number to a 5, what's going to happen to my number?
It will be 5. It's because it's the same thing as saying my string equals hello.
Okay, so hold your horses, Jordan. Yeah, you understand it, but it's confusing in the beginning. Like, what? It changed to a 5. But I thought primitive data types are immutable, right? So what is going on here? Technically, guys, or technically, physically, theoretically, and what I'm doing is I'm actually replacing that 1 to a different value. So now I have in memory, for example, my number, right? I have it as 1 in memory. And now what happens, I'm reassigning my variable here to a 5. I'm not changing the 1. I'm not doing some magic to changing the 1. I'm actually now what I'm doing in memory, I have my number, right? I have my number and it was first 1, sorry. And now I'm just gonna say bye, go to garbage collector, for example. It's erasing that 1, right? It's not modifying it. And then it's changing my number to a 5, right? It's very important to understand, right? It's not modifying this primitive value. It's just changing the value in my variable, right? Cool. And now, זה בזיכרון אחר?
זיכרון אחר בשם number, my number?
I think it's in the same zikaron. It's just changing. Yeah, it's changing to a different zikaron. It's changing. It's deleting this, and then it's creating a new memory, right, somewhere, and it's pointing my number to 5 exactly. Yeah.
רגע, אבל זה גם עובד לפי מצביעים, כי אמרת שיש הבדל שה-primitive type זה לא לפי מצביע.
נכון. But what happens here is I'm creating a new value. I'm deleting this value, right? The garbage collector is taking it, and I'm giving a new value to it. So I'm deleting this one over here. So
עדיין כתוב איפשהו, פשוט. כאילו, לא מצביע, אלא אין לך כתובת 5 נמצא פה, אלא פשוט יש לך קובייה שמחזיקה 5.
הגרבג' קולקטור זרוק אותו לפח בסוף.
It's working lapach. It's not there anymore. It's bye-bye. It's somewhere. It's deleting it, right? And then I'm just going to get a new thing in memory.
אבל לא הבנתי מה ההבדל בין מצביע של אובייקט, למשתנה פרימיטיבי, איך זה נשמע, כאילו, אם זה לא מצביע, אז איך זה נשמע?
זה נשמע בזיכרון, אבל this my array, right, is storing the reference. It's not storing the actual value. The value is in memory, right? But I'm just my array here is only storing the reference. It's not directly accessing the value.
פשוט יש לך מקומות בזיכרון שהם יותר נגישים ומקומות בזיכרון שהם פחות נגישים. אז במקום הנגיש יותר תוחזק רק הכתובת במקרה של מצביע, ולעומת זאת במספר זה יוחזק ישירות במקום הנגיש.
Okay, so guys, let's check this out. Let's have now, let's check an object, right? Objects are mutable, right? You can change them. So if I have const my, I'll just do RRR, right? I have 1, 2, 3, 4, right? And now I'm just going to change my RRRR 0, oops, 0. To something called hello, right? What's going to happen now to my RRR, right? What's going to happen? It's going to get the hello, right? Because you can change them because they are mutable. Because it's in the heap memory, heap memory is more sophisticated, it's dynamic. You can change things, you're allowed to change things, but in the stack, it's more static. You're not allowed to change things in memory. They're not allowed you to change that specific value in memory. That's how it works, right? That's why the heap also takes a longer time, because also it's not placed as a stack one after another. It's placing in many different places, and also it's dynamic. You can see that it's dynamic here because I could change a value on the fly inside memory, right? And it's no problem on that, okay? So that's it, guys. Of course, we could learn so much more about this, about the heap and about the stack, right? But this is a good introduction. And if you understand this, guys, really nail this, because maybe in job interviews, they'll ask about this, okay? I'm going to modify this, what I have over here, to make it more understandable, right? So I'll give this to you guys in reference, okay? I hope that was understandable. Yeah, it took me some time to do this because it is a bit more complicated, right? We could go more deeper, but I don't want to go more deeper because I just want you to get the basics of it. So Baba, that's
the heap and the stack. Can you say, יכול להוסיף על זה קצת על המילים האלה?
Just basically, if you look at the stack, right? It's stored as a stack. So basically it's one after another. I need like a whiteboard here. Really, it's really annoying me. I have no whiteboard, I can't see. So it's kind of like a stack, one after another, right? Here I have a value in memory, value memory, value memory, value memory, and value memory. And a heap is basically everywhere. There's a value over here, for example, and then there's a value over here in memory, and there's a value somewhere over here in memory. It's like scattered all around, right? Then I have pointers, references, that reference to each one of these elements in my memory. That's like a brief overview of how it works, right? But I don't want to get into too much. I could give you some kind of article that shows you nice diagrams and you understand it so much more easier, right? Because I have no whiteboard.
למה זה עובד ככה?
למה זה עובד? לא יודע. למה זה עובד ככה? I don't know too much about inside the memory, but we could definitely read articles, understand it, why it works like that. Just the stack is much more faster. That I know, right? It's much more faster because it's not scattered around, right? And I have direct access to the memory. So that's why primitive data, it's not complicated. It doesn't have a lot of strings, a lot of bytes to store, right? It's usually very small. That's why I'm going to store it in the stack. It's more efficient, but heap is more complicated because I got to have objects of objects of objects. I can have a lot of bytes and it's stored somewhere else because if it's stored in the stack, it just can't handle it. You have certain amount of memory in the stack to hold, right? And if you do complicated objects inside the stack, you'll just get overwhelmed and you have no more memory, okay? But so I'll give you an article about this, okay? This is not too important for your future job interviews, okay? You can get definitely inside this if you want to, but this is the most important stuff, guys, okay?